we're going to start a whole new unit. As I mentioned, it's going to be from here until spring break, which is the end of the quarter, and the third quarter, and it's going to focus all on radicals. Some of this will be review, some of it will be new but still familiar. Okay, so about 2.5 weeks on radicals, starting with taking nth roots. So you guys know how to take square roots. I'm going to show you third roots, fourth roots. How do you take the fifth root of something? Okay, that's what they mean by nth root. So far you guys are very familiar with like square root of 16. Okay, but what about the third root of 16 or the fourth root of 16? What are those, or how can you approximate those decimals if they're not perfect cubes or perfect fourths? Okay. So here's one way to look at it. Okay. Remember that square root comes from a shape, actual shape, area of a square. So the square root of 4, it's asking you, the question of square root of 4 is asking you, what's the side length? So square root of 4 equals 2, meaning the side of the square would be 2. 2 times 2 is 4. The square root of 9 equals 3 because that's the side or length of a square. And remember, on a square, they're all the same length. So if I know this is 3, every single one's 3 around. So the question is, what if I tell you 8? What if it's 8? Is that bigger or smaller? Okay, a little bit bigger than 4, but smaller than 9. So the question is, the square root of 8 is about what decimal, approximately? Without using a calculator, without anything else, the square root of 8 equals approximately what? So here's what you're going to use. If you know that the square root of 4 equals 2, and the square root of 9 equals 3, you know that the square root of 8 is right here. Square root of 8, square root of 9. So the square roots go in order. So this is like 2.8, just an approximation. So I can give you any square root, and you should be able to approximate it just by knowing, well, square root of 4, 9, 16, 25, 36, 49, 64, 81, and 100. I'm not going to give you anything bigger than that. Okay. So square root of 15. So the square root of 15 would be about what? Yeah, the square root of 9 is 3, the square root of 16 is 4. So square root of 15, it's a little bit smaller than square root of 16, so it's a little bit smaller than 4. Square root of 15 is going to be right around there. 3.9 or 3.85 or something like that. I'm going to say approximately. So we don't want to instantly go to the calculator and say what it is. We can approximate it when we need to. And this will come in handy a lot. There's going to be a lot of square roots we're going to be doing the rest of the school year, fourth quarter as well. And maybe up to 2 or 3 times per problem. And you don't want to constantly be pressing all these calculator buttons, getting these long decimals. We really don't need that. Alright, so for you guys, what's approximately square root of 3? What would that be equal to approximately? Yes. So in here, it's square root of 3 and then square root of 2. So square root of 2, square root of 3, and then square root of 4. So it's about 1.7, around there. What about square root of 68? 68, right between 64 and 81. Closer to 64. So that's probably like, I don't know, 8 point, what do you think? 8.2-ish. And kind of like statistics, this is an estimate. This isn't like if someone else put 8.3, they're both right. That's what this symbol right here allows you to do. It's an approximation that gets you off the hook. So that's going to be one part. It's just approximating square roots without using the calculator. Okay, next, cube roots. Let's talk about cube roots. All right. So up to this point, this symbol has always meant the same thing. What times itself, what number times itself, 2 times equals 4, and the two numbers have to be the same, right? So technically it's square root, so 2 times. That's why there's 2 of them here. And we come up with 2. So that's why the square root of 4 equals 2. What if I ask you about the cube root of, let's say, 8? So very similar, but instead of square root and having 2 numbers, it's third root or cube root, so you have 3. So what times itself 3 times is equal to 8? And then you get 2. 2 times 2 times 2. So the cube root of 8 is equal to 2. So one thing that's going to be different for you is adjusting, because you're so used to always doing the same thing. Every time you see this radical, you always assumed, and it always has been, a square root. And now you're going to have to really pay attention to what number is here. If there is no number here, it's automatically a 2. It's automatically a square root, just like you've always known. But there might be a new number here now, so you might have to think about, all right, not just 2 times, but maybe 1, 2, 3 numbers. Let's do a few more to get the hang of it. Cube root of 64. So what times itself 3 times is 64. My advice is to start with 2, and we already know it's 2 times 2 times 2 is 8, and then just work your way up until you get to it. These are going to be perfect cubes, by the way. There's no decimals involved. So it's about finding the right number. What times itself 3 times equals 64? And you come up with 4. 4 times 4 times 4 is 64. So the cube root of 64 is 4. Okay. How about the 4th root of 81? Not the square root, but the 4th root. So what times itself 4 times? All 4 are the same number, and that equals 81.
3.
Is that true? So 3 times 3 is 9. This 3 times 3 would be 9. 9 times 9 is 81. So yeah, the 4th root of 81 is 3. Okay, I think we're getting it. Okay, one more piece of this. Square root of -1. So what times itself equals -1? And you come up with, yeah, -1 times -1, well, that equals +1, so that doesn't work. They have to be the same number, right? Those have to be the same. So conclusion? Yeah, no real solution. Yeah, no number times itself can equal a negative, because a positive times a positive is a positive, and a negative times a negative equals a positive. And you only have 2 numbers, and they have to be the same number, so there's no other possibilities. That's the only 2 possibilities, and both give me a positive answer.
What if it was cubed?
Yeah, so the question is, what if it's the cube root of -1? So is there a number multiplied by itself 3 times that equals -1?
Yes.
And you come up with -1, right? So new concept, of course, is the cube root. There's a subtopic in here built in that you have an assumption every time there's a negative underneath the radical, there's no solution. That's not true any longer. Since we're looking at cube roots, we can see, well, -1 times -1 times -1, that's an answer. So even though there's a negative here, you're not going to automatically say no solution anymore. You have to check out and see what root it is. If it's an odd root, anything with an odd root, you can have a negative inside the radical. So if it's the fifth root, you could do that as well. So like the fifth root of -1, that also equals -1. -1 times -1 times -1 times -1 times -1, right? This equals, that all works. But if it's an even root, there's no way to get a negative. It's having that these two pairs, see, these cancel and make a positive, these two pairs cancel and make a positive, but having that odd number, you always have one more negative that'll make the whole answer negative. So you have to have an odd number here in order to have a negative answer. So that's a little thing, just be careful. A lot of times we see students, they're so used to saying no solution with a negative underneath the square root. Okay, besides that, it's going to be pretty straightforward. We're going to throw in some variables as well. It's not going to be all numbers. Okay. And please, nobody's allowed to say if it has a fraction, it's harder. Please, 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 please. So the square root of 1 over 25. What times what equals 1 over 25? Yeah, 1 over 5. 1/5 times 1/5. Right? Same thing here. Cube root of 125. 1 over 125. So same thing. 1/5 times 1/5 times 1/5 equals 1 over 125. What's that? Negative exponents you're thinking of, I think. Yeah. Yeah, we'll tomorrow we'll be doing fraction exponents, and then we'll get into negative exponents. Yeah, it'll be a lot of different things going on. You know how you guys are super familiar and can recognize 4, 9, 16, 25, 36 super easily. Well, you want to get used to 1, 8, 27, 64, 125, 2, 16, 3, 43, 5, 12, and so on. So this is 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, and so on. And just as we use these more and more and more, you'll just get used to them. So when you want to approximate the cube root of 150, you already know that, okay, that's 5 cubed is equal to 125, so that's like 5.4-ish. Okay. That will just take some getting used to. And you'll have number lines on your homework to draw them out. Okay. So that's what I'm going to start you off with, and then I'll go over some of the variable questions like this after you guys get started, okay? But more or less it's the same thing. What times itself 3 times equals 27c to the third? Well, the 27 is 3 times 3 times 3, and the c is to the third is c times c times c, so that's just 3c. So with the variables, it works the same. It's just, again, more getting used to than difficult. As soon as we see what's going on, it kind of makes sense. Okay? All right, let you guys get started.